Well, thank you very much for the invitation. What I'm going to talk about is the Durham weather records from 1841, mainly to focus on temperature. That's what I was asked to do, but I'll just stray into precipitation and sunshine towards the end of the talk, just to draw some other threads together. Here's the Durham Observatory, built in 1841, and we have daily records from 1843. There are probably earlier ones that are hidden somewhere in the university library, but this is still the second oldest university weather station in the country. I've been lucky enough to run the two oldest weather stations. I ran the Oxford University Radcliffe Meteorological Station for 10 years, 86 to 96. And then since 2001, I've looked after the Durham weather records. We don't any longer, we haven't had an observer going out every day since 1999, when the university in its wisdom decided to end that particular method of observation. But the Met Office have installed an automatic weather station, and so I get a daily file of data to keep me informed. And it doesn't actually matter that I live in Devon, because I probably see more Durham weather data than anybody else, even those living in the city. Stephen Burt, who's no relation, and I published a book about Oxford weather and climate in 2019, and we're now working on Durham weather and climate since 1841. I don't know what the front cover will look like, but this is my own sort of mock-up, as it were, with the big flood, the maximum flood of June the 3rd, 2000. At the top, my son sat on a bench, and then a week later, the Durham Regatta. You can see the contrast there. And just a quick word about why these long time series are important. I think there are three basic reasons. First of all, these long time series reveal important patterns for scientists to explain, particularly weak signals in noisy records, which is often the case with climatic records. Long data sets are essential for testing hypotheses undreamt of at the time the monitoring was set up. And global warming is a good example of that, of course. And monitoring is a vital way of showing whether there are undesirable changes taking place in our environment. We've heard about the Holocene context already, so I don't really need to concentrate on that. Just perhaps to mention that when we get to the decline from the optimum about sort of 5,000 years ago, this is when the peats on the top of the Pennines began to form, and they're an important carbon store and remain so. And one of my research interests has been looking at peat erosion and trying to stop that in order to conserve and build up carbon stocks of our Pennine peatlands. But you can see the way that we declined through into what's labelled here a neoglacial, and about 200–300 years ago we were into the Little Ice Age, which we came out of, but then global warming has shot us well above anything that we've seen in the Holocene previously. So this is the crucial slide, I suppose. Here's the Durham mean air temperature since 1850. I apologise for not taking it back to 1843, but I've had a bit of computer problems for the last week or two, and so it was easier to use a graph that I knew was there rather than to try and wrestle with a new one. The green line through the middle is mean air temperature, with mean maximum and mean minimum from 1900, when the Stephenson screen was installed. Before that, we can construct a record, but it's not quite so certain as with the Stephenson screen. And at the bottom, Ed Hawkins from Reading University is a great producer of climate stripes. And to be frank, if I just needed to show you one image, I could just show you the climate stripe, and that would be better than the whole talk, I think, because it very clearly shows the difference from the early part of the record, which varies around some very cold years in the late 1870s, early 1880s, and a mixture of blues and orange, really through to 1950. And then, as the previous speaker pointed out, we've begun to come out of that, particularly in the UK from the 70s and 80s. The 60s was actually a bit of a cool decade, and then we ran through to warmer years, the big drought of 75, 76, which some of the older in the audience will remember, and then through into very warm years from 1990s onwards. So that transition from dark blue to dark red over 170 years is exemplified in the Durham temperature records, and that long time series tells us all we need to know. Now, the man who established the Durham temperature record as we know it today is a man called Gordon Manley, who was the first head of the geography department. I think he came to Durham in 1928, and he was very keen to get the Durham temperature record, as well known as the Oxford University record. And from his interest in the Durham record, he then built up something called the Central England temperature record. And if you go into the department head's office in geography, hanging on the wall framed is Manley's original graph, which it was drawn originally through to just about 1950. His first paper on the CET was 53. And at some stage, Manley then updated it through to the late 70s, just before he died in 1980. So the Durham record lies slightly outside Manley's area for CET, which is more the sort of North Midlands, south sort of Lancashire and Yorkshire. But nevertheless, it's the same sort of pattern that you can see from the mid-19th century. What Manley did was that he was able to go back to 1659, so that in terms of UK temperature record reconstructed from various records, this is what we have here. And it's easy to take Manley's record and cross-correlate with Durham. You get a pretty good correlation. And what I've got on this graph are really sort of three bits. We've got the green, which is the actual mean air temperature record. Before that, we've got an extension that was originally done by Gordon Manley and improved on by a PhD student at Durham, Matthew Eglise, whose PhD was examined in 2003. And then before the Eglise extension, or the Eglise-Manley extension, if you like, we can then go back to 1659. So you can see the Little Ice Age in the latter part of the 17th century, and you can see that's the coldest period on our record, just looking at essentially half-century periods. The temperatures then waggle around, a bit warmer and a bit cooler, warmer at the start of the 1800s, then cooler, warmer at the start of the second part of the 1800s, and then a bit cooler. And then we gradually come out of that, particularly running up through more recent decades. So back here, we're down around 7 in the Little Ice Age. Now we've had a number of years which have got up to 10. So a 3 degrees C increase over that period. Most of it, as you can see from the table, coming in the last 70 years. So that's, I think, of interest. The coldest year in the Central England temperature record is 1740. Very cold winter, 1739-40. 1684 was also cold. Interesting here, we've got 1816, the year without a summer, which shows up very clearly in the Durham extension record, and shows up also in SET and in the Oxford record. This is follows the eruption of the Indonesian volcano Tambora in 1815, and that's a very clear indication of the impact of particles in the atmosphere on sunshine and temperature, and I'll come back to that. If we come through to 1912, we also see a cooler year, and you'll see me refer to that again very shortly. Gordon Manley recognized that this was the result of an eruption of Mount Katmai in Alaska, and that had a shorter, less impact on less impact on the temperature record, but very clear on sunshine. Interesting, Krakatoa doesn't show up with so much impact on climate, but these signals are there. So it's mainly a human impact, but there is some natural impact as well. Here's the Durham precipitation record from 1815, and there's no particular pattern here in terms of long-term trends. There are wetter and drier periods. The most recent 20 years has shown some tendency to get wetter. Whether that's a climate signal or not, it's too early to say. If I'd indulged and shown you the Oxford precipitation record from the 1760s, you can see a long-term trend through the whole Oxford record. It's an untested hypothesis as yet, and it's just possible that global warming is going to increase precipitation in the way that Liz explained with Antarctic snowfall. No impact, as far as I can see, on the annual maximum daily rainfall. We've got the biggest impact here, 1976, 10th of September, but there's no apparent increase in the heaviest falls of rain. And then just to show you hours of bright sunshine, we've got a Durham record from 1880, the second earliest anywhere in the country after Oxford. And it's just a pity that there's a bit of an early gap, which doesn't really show up on my graph, but 1883-4 is missing. And so if there was an impact of Krakatoa, we can't see it in the Durham record. But we can see Manley's Mount Katmai, and you can see that very easiest, the dullest year on record at Durham is 1912. And it wasn't so much that I wanted to show as this improvement here. And this, I think, is all to do with the end of coal fires and the improvement of air quality from the Clean Air Acts in the 1950s onwards. I suspect in Durham it took a bit longer to clean up the atmosphere than in some other places, simply because so many people were still burning coal and the coal industry was still operating. But you can see that what we've had in the last 40 years has been well ahead of anything that we've seen before. So there's a very quick reference to the Durham weather records. There are already some available online. If anybody needs data, come to me. And once we get our book published next year, as we did in Oxford, there'll be a big data set available for free access, which is exactly how it should be. Thank you very much.
Well, thanks very much, Tim, to give us an insight into the more recent record. And I'm sure we all look forward to the book being published and having a look through that.